Hello guys, welcome once again to Code with Destiny. Today we're going to talk about linked list. So get ready and yeah, let's get started. Alright, so a linked list is a linear data structure where elements are not stored in contiguous memory sections like in arrays. Instead, each element is a node, like shown in this diagram. Each element is a node that contains data and a pointer. So that is the arrows here are pointers to the next element. So it's like to the next element. This structure allows for dynamic memory allocation and efficient insertion and deletion. So like in arrays, when you delete an element, you have to like reallocate the other element, like because like you have to like readjust the locations of the previous element. But in linked list, when you remove an element or insert a new one, you just need to organize the pointers, just rearrange the pointer to and from this element, so you don't even need to touch the other elements. That's why linked lists are very good for insertion and deletion. But for iteration or like for like counting through like the elements, it's a very bad data structure for that. So whenever you have an algorithm that needs a lot of insertion and deletion, is a sign that yeah, you need to use linked lists. Alright, so I pre-wrote all the code to make the video a bit short. For a linked list, this is the data structure. Is a structure in C++. We don't have a default like realization of linked list, so it's you actually do this by ourselves, but it's not that hard. So this is basically how you do. You create a node or whatever name you want to call it, but preferably just node. Then inside this structure, you have a field of data and a pointer to a node that is pointer to the next node, like I showed in the picture. So to insert an element into like at a new node, to the beginning of the list, this is the function for that. Accept a reference to the head. As like the head is like pointer to the last element that was inserted there, and then the data you want to insert at this new node. So you create a new node, use new here because you want to dynamically allocate memory. You don't want to like specifically put it in a particular location. You want the memory allocator to basically just look for a particular section and just allocate data there. Then here you set the data of this new node to the new data, and then you set the next pointer to point to the head, and then you make this new node the new head. I know that's kind of not very clear. That's why I'm going to show it in this form. So basically, let me connect my again. Okay, so basically, let's say you created a new node here, and then you have some data. It has data that we collected. This head here is the previous head, which is pointer to like the last element that was inserted. So usually a node has a head, a data, and next. So what we did was that we made this head, we got the pointer of this head and then allocated it and made it point to the next of this. So the next here will now be the whatever the head was pointing to, and then what we did in the last line was making the head point to this new data. So it's new to this new node we created. So this line here is just rearranging the head. That is like making this new node that we created the head, and then this line here, the line before that, where we are setting the next element to whatever the head was pointing to. It's like we're getting the like going one step lower from like, you know, we use 2 pointers here. That's like they put this like pointer to the head, then here we're getting whatever the head was pointing to. That's like the first element. I hope that was clear enough. If not, write in the comment section and I will come back and answer you. So to print a linked list, you just iterate through the nodes until you get to the null pointer. That's because the last element always points to null. So you keep iterating till you get a null pointer and then keep printing out the data. That's not really hard. So this is an example of how you create a new, initially the first element is the head, you make it point to the null, which is usually the first. That's like here, this one here, the first element, you make it point to null, and then you push, you use the address of this head as the pointer, and then this is the data, and then this new element that you inserted becomes the new head, and then you push data, you arrange the data. So basically linked list is not that complicated. It's actually very useful when you have a lot of insertion and deletion, and it's like big O of 1, that is like the time complexity of insertion and deletion from the beginning of the linked list is constant time. So let's run this and see if everything works clearly. Oh, my keyboard is in Russian. So let's compile. And yeah, created linked list 3417. These are the data. So basically that's that for linked list. That was a very quick intro to linked list. So practice creating, deleting elements and all that. Then realize a linked list for me in the comment section. Write a code to realize a linked list, a double linked list. Yeah, like where you create pointers to point to both elements, to point to previous and the next. Write the structure for that for me in the comment section. I don't want to do that because like I want to give you something to do. All right, thanks for watching. Like and subscribe, and wait for the next one. Keep watching to learn more. Thank you.